Hi guys, welcome to ITR Expert again.
In this video of the ITRXCEL course, we cover conditional functions and prepare for exercise 17.
Imagine transforming your spreadsheet in a smart assistant that can make decisions based on the data you provide. Here is where conditional functions, such as if or if-else, can help. In this video, firstly we will cover the if function, its basic structure and real-life examples when the if function can be really handy. Also, we will cover nesting, which refers to the practice of joining multiple functions together in one formula. For example, combine the if function with logical formulas, such as the and, the or, and the not functions to enable multiple conditions. Also, we'll cover the nesting of multiple if functions together, comparing it with the new if-else function. Finally, we will cover the if-error function, which is very useful in financial spreadsheets to eliminate false errors. The if function allows you to make a logical comparison between a value and what you expect by testing for a condition and returning a result if that condition is true or false. Think of the if function as a simple question: if this condition is true, do this, otherwise, do that. For example, you could use it to check if a sale has exceeded a target and automatically calculate a bonus. This transforms your spreadsheet from a static display of numbers into an active tool for analysis and decision making. So, the if function is composed by three blocks, separated by commas. Block 1 is the logical test. Block 2 is called value if true and is what we want Excel to do if the condition is true. Block 3 is called value if false and is what we want Excel to do if the condition is false. In block 1, we basically ask to Excel to check if something is true, so we set a condition. For example, we can check if a cell value is 0. We can ask Excel to check both for a text or a numerical value. When checking a text, needs to be between quotation marks. To check if C2 is yes, we need to write C2 equal, open quotation mark, yes, close quotation mark. We can check for any text and Excel will compare the two text string and return true when there is an exact match. Here if yes, Excel will write 1 in D2, if no, it will write 2. When checking for a numerical value, we can check if a cell's value is equal to something bigger or smaller. For example, we could check if our food expenses in a cell are equal, higher, or lower than the weekly food budget, writing B for equal to £100, or B for bigger than £100, or B for smaller than £100. In this example, we check if C2 is equal to 1. We write equal if, open brackets, C2 equal 1, comma, then write open quotation mark, yes, close quotation mark, comma, otherwise write open quotation mark, no, close quotation mark. The next example checks if the expenses in cell C2 are bigger than the budget in B2. Excel will write over budget in cell D2. If is not bigger, it will write within budget. In block 2, we need to tell Excel what to do if the condition is true. This can be a text, a value, or even a nested formula in more complex tasks. In block 3, we need to tell Excel what to do if the condition is false. Remember, any text needs to be between quotation marks and Excel will write that text inside the cell. For both block 2 and block 3, we are not limited in returning single results for both true and false conditions. They both can be either a text, a value, or even a nested formula, performing additional calculations depending on your criteria, or nesting multiple if functions to perform multiple comparisons. In this example, the if function in D2 check if C2 is greater than B2, then instead of returning a single value or a text result, we are going to return a mathematical calculation. We write in E2 equal, if, open brackets, check if the C2 is bigger than B2, then C2 minus B2, otherwise 0, close bracket, enter. In the next example, the formula in F7 is saying if E7 equals a yes, then calculate the total amount in F5 times 8.25%, otherwise no sales tax is due, so return 0. Sometimes things go wrong when using this formula for the first times, and we have some errors. It can return a 0 when there is no argument for either value if true or value if false arguments. To see the right value returned, add argument text to the two arguments, or add true or false to the argument. It is also common to have the hash name error, which usually means that the formula is misspelled.
But what if you need to test multiple conditions? Let's say we need all the conditions to be true, or at least one or only one condition needs to be true. Also, what if you want to check if a condition does not meet your criteria?
In these situations, when we want to check multiple conditions, we can integrate it with other logical functions. For example, we can use the AND function to check that both conditions are true, the OR function to check that at least one is true, and the NOT function to invert the condition to false instead true. It is important to remember that we should always close brackets before finalizing the formula with enter when using nested formulas. This will help to avoid error messages. Sometimes we might need to evaluate more complex scenarios with multiple checks that require nesting more than 3 if functions together. Excel will allow you to nest up to 64 different if functions, but it's not at all advisable to do so because multiple if statements require a great deal of thought to build correctly and make sure that their logic can calculate correctly through each condition all the way to the end. If you don't nest your formula 100% accurately, then it might return unexpected results. Multiple if statements can become incredibly difficult to maintain, especially when you come back some time later and try to figure out what you or someone else was trying to do. The if-else function is a better option than nesting many if functions, because it can check whether even multiple conditions are met without nesting and returns a value that corresponds to the first true condition. Also, the if-else function is much easier to read with multiple conditions. In this example, we want to return a letter grade instead the score grade. The formula for cells A2, A6 check if A2 is greater than 89, then return an A. If A2 is greater than 79, then return a B, and so on, and for all other values less than 59, return an F. This formula allows you to perform several logical tests against a range of benchmarks without the needs of other nested formulas. Finally, let's have a look to the if-error function. Very simple, but very useful nested formulas to eliminate errors returned by other formulas. If error, when the main formula returns an error, it will replace the error with a value you specify, otherwise, it will return the result of the formula. In this example, as the unit sold can be 0, we may have an error when divide the quota by 0, like in row 3 where we need to divide 55 by 0. To avoid this error, we could ask to return a 0 and write the formula as equal, if error, open brackets, enter the main formula, comma, and a 0 as the value if error, close brackets, enter. Do not forget to close brackets. By mastering conditional formulas, you'll elevate your Excel skills and unlock a world of possibilities for data analysis, automation, and report generation. Even though these formulas look quite challenging, do not panic as we will cover them more in detail with plenty of practical exercises applied to real-world scenarios.
Great explanation, Jay. Well done everyone, and keep up with the good work to master the if function.
If you like this video, please hit the thumbs up. Subscribe to the channel and click the notification bell. Thank you.